If sine of alpha is negative 3 over 5 and it's between pi and 3 pi over 2, and cosine of beta is 12 over 13 and it's between 0 and pi over 2, find sine of alpha plus beta. So sine of alpha plus beta equals sine of negative 3 over 5 plus 12 over 13. No, this is not correct. Sine of alpha is negative 3 over 5, so you plug that right into the equation. It's not sine of negative 3 over 5. That's one common mistake that people make. So this is the equation. Sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And we're going to find all these things, all these components of the equation by first making a triangle, and we know that the alpha triangle is going between pi and 3 pi over 2, so in the third quadrant. So we solve to get x equaling 4, and we use the Pythagorean theorem to find that out. So now we know that sine of alpha equals negative 3 over 5, and the cosine of alpha is 4 over 5. Now for the beta triangle, it's going to be between 0 and pi over 2, and we can find the x by knowing the 12 and the 13, the hypotenuse and the one leg. So we can find x as the other leg, so we can find sine of this triangle. So 13 squared equals 12 squared plus x squared, 25 equals x squared, and 5 equals x. So cosine of beta is 12 over 13, which was given already, and sine of beta equals 5 over 13. Now we plug everything into the equation. Sine of alpha equals negative 3 over 5, multiply the cosine of beta, which is 12 over 13, plus the cosine of alpha, which is 4 over 5, times sine of beta, which is 5 over 13. We plug it all together. We know there's a common denominator of 65, so we can just put that right over 65, and 3 times 12 is negative 15, and 4 times 5 equals 20. So negative 15 plus 20 equals 5 over 65. We have to divide by 5 on the numerator and the denominator to simplify the equation further, and the problem is equal to 1 over 13.